Hello, folks. Welcome to the Solar Fit Renewable Energy Show. This is Bill Gallagher. Mighty glad you joined us today. Another beautiful day in Flagler County. And we have an exciting show. We have Embry-Riddle's finest, some of their engineers with us today. In fact, the studio is full. We had to pull in chairs from outside, so this is going to be a lot of fun. And before we do that, I want to tell you that we did have a call this week from Janet in Ormond Beach, and she wanted to know the following question. If we solar fit our home, do we need batteries? Janet, that is an excellent question, and there's a couple of different answers to it. We do sell solar systems with batteries, but most of the time our grid interconnect systems do not have batteries. The power is fed directly into your breaker box and causes your meter to spin backwards, which is really nice to see. And any excess energy is sold back to the utility company at full retail, which is really pretty cool when you think about it. So when you're away at work or on vacation and you're not using as much energy as normal, that energy is being fed back and you are being paid by the utility company. So free energy, how can you beat that? Janet, thanks so much for your phone call. Folks, if you have a question, call in our office at 386-445-7606 and say that you listen regularly to WNZF radio, NewsRadio, and you got a question for the renewable guy, that would be me, and we'll read it on air next week. So call in if you can. Okay, Guy, we're here today with Derek, Stephen, Yuchi, and Matthew from Embry-Riddle. Hello, guys.
Hi there.
How's it going?
Very good. Welcome to the show.
Thanks so much.
All right, so this is really an honor to have you all come at one time. Hey, Derek, let's start with you. Tell us a little bit about your background.
Okay, so I joined Embry-Riddle. I came on board as an aerospace engineer, switched to mechanical. I'm from New York City. I originally went there to do things with aeronautics and astronautics, but I switched to the automotive track, because I realized that the mechanical engineering department is doing a lot of cool stuff too, and I was just better suited to that kind of thing. And so I'm on the controls team of EcoCar, and I basically decide how the car works.
Wow, the controls team now, that is actually controlling the motivation of the vehicle? What is that exactly?
Right. It's basically the programming, interfacing, and mapping out of all of the different functions of the vehicle. And so we're adding a whole bunch of proprietary components that don't necessarily work together, but we have this supervisory controller that we add that basically tells everything what to do, budgets power, and makes it so that all of the components work in sync to give you an efficient, drivable vehicle.
Geez, awesome. We're going to get to the car in just a minute. And hey, Stephen, how about your background?
Well, originally I grew up in Kansas, Hutchinson, Kansas to be exact. Came to Embry-Riddle in 2010 as a mechanical engineering student. I just knew that I wanted to work on cars and make things go fast, and Embry-Riddle promised to help me out with that. So far, they're doing a pretty good job at it.
Well, we had a meeting yesterday, the Board of Visitors meeting, and I was really surprised and pleased to hear that Embry-Riddle is now going to be kind of reaching out to NASCAR and have a program specifically designed for high-performance vehicles as well. It never ceases to amaze me, all the different things that are happening at the university.
Yeah, it's truly an awesome thing. I do remember one of the things that we did with NASCAR a couple of years ago was working with them on their track drying systems to see if we could figure out a way to make the jets dry the track out faster after a rainstorm. So we worked with them on that project.
People don't think about that, but you're right. That is a very important feature. You've got 200,000 people in the stands, and they're soaking wet and they're cold, and they want to see the race go on. So every minute you can shave off that, almost like a pit stop, and it's real important stuff. Mm-hmm. And I'd like to hear all about that too here. Well, Yuji, you're from China, I understand. Tell us about your background.
Oh, yeah. I came from Beijing, China, and been here in the United States since 2008. And I was doing my undergrad in computer engineering, also in Rideau. And I changed my major when I got to graduate school. I decided to do mechanical engineering because I don't feel like, sitting in front of the computer all day and typing all that kind of stuff. And I really like it. And now I'm working on the mechanical team in the EcoCar. Basically, like Derek said before, he's the controls team. Basically, decide, what all the components do. And we are the guy who put all the components together to let him have something he can test on and, a whole working car.
Oh, my goodness. Well, I have to ask, how did you hear about Embry-Riddle, and how did you happen to come here from China?
Actually, it's kind of like a school communicate students thing. Like back in China, I was admitted in one of the university back in China, and we have a program basically do 2 years, started 2 years in China and 2 years here in the United States, and Embry-Riddle is a school we commuted to, and that's how I know. Actually, to be honest, since Riddle is a private school and it's not that big, I have never heard about it before. And after I came here, it seems to like it. It's a really good school, and I like it a lot here.
Well, it's the best kept secret in Florida for sure.
Yeah, it is.
Well, at the rate that things are improving and building out there, it won't stay a secret for long, that's for sure.
Yeah.
Matthew, how about yourself?
I'm originally from Arlington, Texas. I'm currently a junior in the mechanical engineering department at Embry-Riddle, studying high-performance vehicles. I'm, like Derek, also on the control system team, but my focus is more of helping with the debugging process of the vehicle and then doing automated testing on our supervisory controller.
Yeah, very good. Now, there's a few other folks that weren't able to make it today, and you want to do a little shout-out for them?
Sure. Chester, our mechanical lead, and Chris Rowe, our electrical lead. Wish they could be here with us. They're a big part of the team, and Chester helps get us all rallied together, and Chris does a lot of the electrical work, and of course we have high-voltage batteries and low-voltage systems that all need power, so he's a real big asset there.
Well, the Rowe brothers are great guys and good friends. We've been able to work with them in the past, and we miss them. We wish we were there, but they will be there next time. So let's talk a little bit about the Eco car. Tell us initially a little bit about the design and where we are right now on it.
Well, the Eco car is a series diesel hybrid electric vehicle, so it's kind of like a diesel locomotive in that you have an electric motive system that drives you forward, but you also have a diesel engine generator that sustains the battery once it gets to a low state of charge. And right now the car is pretty much finished being assembled. Right now we're just trying to make it work properly. We're just sorting through the last of our engine issues to try and extract maximum power and efficiency. And we're fine-tuning the operating points so that we can use as little fuel as possible and make as little noxious exhaust as possible. And then we should have a car that's all set for competition in June.
Okay, we're going to talk about the competition in just a minute, but speaking of fine-tuning, I was out to the college, the university, maybe 2 months ago, and they were just setting up the dyno. How's that going?
Oh, it's been a real big asset for us lately because we can, not only do we have to do power testing and load testing, but we also have to do testing at different speeds that you can't really just achieve on Clyde Morris or anywhere because traffic is unpredictable. So if we want to do precise drive cycles like we're going to do in the competition, it's necessary that we have a dyno. And also we can discharge power very quickly on it, which helps with some of the other testing that we do.
Now, you guys don't sneak in your hot rods to do a little test it now and then, do you?
We wish we could, but the university wouldn't let us.
I think that's probably a good idea. But the first thing that I thought of when I saw that dyno was like, hook your street Hemi up there and see if you can get a, maximum horsepower on it. It's pretty awesome.
I'm part of the muscle car club on campus, and they were trying to have EcoCar let them have a dyno day on campus where students would be able to bring in their car, put it on the dyno, see what kind of numbers they're getting, and just make a big event out of it. Maybe even have a car show like what they're having in a couple weeks. But the insurance company for the school was not a huge fan of that at all.
Yeah. When you say muscle car, tell me a little bit about that. What's that?
It's the Embry-Riddle Muscle Car Association. It's an organization on campus where students who are enthusiastic with muscle cars, new or old, can get together, have conversations. We help each other out working on the cars when necessary, and we just have a good time.
What's the hottest car out there?
It's not out there anymore. I think Stephen Fox had a Shelby GT500 that was putting quite a bit of power to the wheels. Or Jason Sabres has a early 2000s Camaro with a lot of engine modifications done to it, pushing quite a bit of power. Last time he was at the drag strip, he shattered his differential.
Wow. Well, that's awesome. Here's a little bit of trivia for you going way back, maybe 45 years ago. My uncle, when he lived here in Daytona Beach, was very, pro young folks, and he would actually get the young folks together down at Spruce Creek Airport, was the airport at the time, and they would have drag races. It was not a sanctioned event. It was just where they could go in a safe way and without getting on the streets and run their cars. So that's pretty interesting. Now it's a fly-in community and really doing well.
It really is a great idea. The closest drag strip is a 45-minute to an hour drive away, so it's a great way to keep people from racing on the streets.
Exactly. Exactly. You're not a drag racer, are you?
No.
No.
I hope I'm.
They have drag racing in China?
Oh, actually, no.
No.
Yeah, I've never heard about drag race before I came to the
Really?
United States. But yeah, but it's really interesting. I really hope, we have something like that back in China.
Well, what do they call it now? The drifting? Do you ever watch the drifting? Any of the...
Oh, is that the movie or?
No, it's actually, it's kind of you guys know what I'm talking about?
Yeah.
Yeah, where they actually, they go,
Get the rear end out.
yeah, they get the rear end broken loose and they just go around the corners.
Yeah, I know that.
That is a lot of fun to watch.
Yeah.
Jeez. So let's see the car itself. We know a little bit about the propulsion, but, tell me more about how that works and how it differs from a standard automobile.
Well, a standard car has its primary motive force being provided by the engine. The engine's connected to the wheels through a transmission and a differential, and you drive that way. But our car is unique in that it only has electric motive force, and your diesel is simply providing electrical energy to the battery while you are drawing out of the battery using the motor and the auxiliary systems and things like that. And it's different because we can operate our engine at the most efficient operating point possible. See, in a normal car, when you get out from a stoplight and you initially hit the gas, you're operating at a low RPM but a high load, and that is actually a bad operating point for your engine in terms of emissions and fuel efficiency. But we don't have to undergo those conditions because our engine's completely decoupled from the wheels. And so when you press on the gas, you might not exactly get the response out of the engine that you would expect, because it's just not coupled to the road, and we know in advance what the most efficient operating points are, and so it's going to seek to operate in those efficient points.
So is it like similar to a true electric car as far as torque, or is there a hesitation? Or
there is no hesitation. It provides perfectly smooth linear torque, and we can control it and fine tune it however we want, because there's just so much freedom in an electric motor. If you want half of its max torque, you get half of its max torque in an instant. You don't have to wait for it, and it doesn't overshoot or undershoot. It just provides exactly the amount of power you want.
Okay. What would be a top speed on a car like this?
The top speed, we have a transaxle that's not exactly designed for this car, and it's only one speed, so it's about 80 miles an hour gear limited. In production, I think they would have a different gear ratio in there, but it's just what we had to select from.
So really the top speed's only limited by the gear to a certain extent, right? So you could gear it to, if you wanted to go 100 and whatever, you could do that. Yeah. Might not make a lot of sense to do that, because where are you going to do that, right?
No.
Right. Yeah.
But if we wanted to go faster, we could.
Yeah. Yeah. What about some of the professors that are helping you out there? Tell us about them.
We have almost every single professor at the university at our disposal, essentially. We're able to ask them any question that could possibly come to our heads, and if they don't know it off the top of theirs, they either know where to look for the information or who to go ask instead. So Dr. Courier, he's our program advisor. He is a great resource for us. He's in the lab almost constantly and is able to answer most of our questions on his own. We also have Dr. Budka and Dr. Barrett in the electrical department that are able to help us out with a lot of our electrical systems.
It's really important to have that faculty advisor role be prominent in a competition like this, because as young engineers, we often get stuck into this rut of trying to make a certain idea work, even when it's not really the best course of action. And so the faculty advisors are really good at looking at things from a global aspect and can kind of pull us out of that if we get into that mode.
Is Dr. Compare working with you folks also?
Yes, he's currently helping us develop our selective catalytic reduction system for our emissions control on our exhaust for the diesel.
Well, he's a great guy, great resource for you. We work with him several years now on the Haiti project, which they're just getting ready to head out for another adventure down there. Do you guys work on that at all?
Yeah,
no, sir.
No, you're
we
too
are
busy.
Yeah, we are not working on that, but we have a couple of guys from our team working on that, and it's a really nice project. But yeah, we are kind of like busy and don't have enough time working on that, because that's also a huge project, and actually building the water filtration devices for Haiti and bring it there and install it, everything. And it's really interesting. I hope I have opportunity and the time to join that project and really contribute on that too.
Well, it is an awesome project, and the amazing thing about it is seeing the expressions on the people's faces when they see clean water for the first time in their life, and carrying buckets for miles to get this free clean water is just we just don't realize sometimes how fortunate we are here in the United States to have clean water anytime we want it. Just turn the tap on. It's pretty cool. Yeah. Well, guys, you know what? We're close to a break. We're going to have to take a short one, so stay with us, folks. We'll be right back. Did you ever think the day would come when you could heat and cool your house using solar power only? Well, the future is here. You can now solar air condition and solar heat your home.
SolarFit sets you free.
A solar comfort heating and air conditioning system offered exclusively by SolarFit. Give us a call and let's talk about solar fitting your home. 445-7606. 445-7606.
SolarFit your life and set yourself free with the sun's free energy.
Hello, folks. Welcome back to the SolarFit Renewable Energy Show. This is Bill Gallagher, and if you just joined us, we're here with Embry-Riddle's finest, Derek, Stephen, Yuchi, and Matthew, and we're talking today about the Embry-Riddle Eco Car team. Guys, before the break, we were learning a little bit about the function of the car and everything, but we've got a competition coming up pretty soon. Tell us about it. Who wants to take a shot at that? How about Matthew? What do you think, Matthew?
Well, the competition is going to be held up in Milford, Michigan at the GM Proving Grounds. And at competition, our vehicle is going to have to be put through all of the dynamic tests a standard production vehicle has to pass, such as the 0 to 60 acceleration test, the 60 to 0 braking, lateral G accelerations, emissions testing, along with a large list of others.
Okay, does Yuchi get to drive this car? Who gets to drive and have all the fun?
Actually, one of the students, it's depending on the different event. Some of the event, there will be a GM driver to drive the car. And actually, there's one student allowed to be like seated in the car to see, what's happening. Actually, we can know the first-hand, have the first-hand feelings about the car. And some of the event, which is like the last dangerous event, it will be driven by a student driver. And there will be a autocross, and actually student got drive the cars for a couple of laps and just have fun. That's pretty interesting. Yeah.
Now, will you all be there for that competition?
Unfortunately, there's a limited number of seats that they have available, and not every member of the team gets to go to the final competition.
How did they select who's going?
Necessary members of the team, such as our team leads and people on the mechanical and electrical teams who have to be there in case something were to break.
Yeah. And how many years has this competition been going on?
This is the third year of this iteration. However, the AVTC competitions have been going on for at least 25 years.
For 25 years?
Yes.
Jeepers, creepers. And Embry-Riddle always places, I don't even have to ask this question. Every time Embry-Riddle goes out, whether it's soccer, baseball, whatever, they're always right at the pinnacle of it. And it's just amazing. You guys do an awesome job.
We appreciate that.
A lot of hard work. So that's a question, how do you manage going to classes and doing all this, and during the break you're telling me you get 85 hours of lab time. My goodness, is that many hours in a week? Oh, I guess there is.
You make it work.
How do you do it?
You have to find a creative way of applying what you're doing in EcoCar to your classes. Maybe you choose a project that's startlingly similar to an EcoCar problem, or vice versa. And you have the faculty advisors at your disposal as well, and you certainly learn a lot more being in the lab, also in addition to being in your classes, and so it helps out quite a bit.
So what would be what's a potential problem? Let's say during a competition, what could happen?
Well, worst case scenario, we blow another engine. If that happens, that's the last of its engine in the Western Hemisphere, so there is no replacement for it.
Yeah, that's actually, we haven't mentioned that yet. Basically, we blew 2 weeks ago, we have an emission testing event in Ohio. We have to ship our car there to a TRC Transportation Research Center, and basically running through the EPA kind of event to see how much emission came out from our tailpipe. And right 2 weeks before that, we blew up our first diesel engine.
Oh.
And it's because one of the timing bolt is loose, and we didn't notice that. It's not torque to specs, and after the engine running for 6 hours, it's just the timing got messed up, and it's just not working. And we have to get a new engine from GM, and that's the only engine in the United States we can get. It took us a week to swap the engine out and put a brand new engine in and get everything back to working condition, and takes the car to the emission testing event. That's quite a week. That's some good time we spent there to trying to get the car back to work, like having 1 week of time before having to go to a huge event.
So did they ship the diesel engine to you on site, or did you bring it up there? Or how did
they ship it to us, and it's amazing, the turnaround time of GM. It's basically, we tell them like one night is like the second day. Well, they said they're going to ship off the engine. It only takes them 1 day to get the engine here down to Daytona Beach.
Wow, why is there only one engine in the northern hemisphere?
Oh, because that's a diesel engine, and in a compact vehicle, in a passenger car, and from what I'm understanding, not a lot of American-made cars have diesel engines. Especially the passenger cars. Like there's only one, I believe, the Cruze diesel coming. The new Cruze, the new Chevrolet Cruze came out have a little diesel engine in it, and most of the diesel engines came from Europe, and the diesel engine we have is a GM design, but it's also built in Europe. So that's the only one here in the United States.
Jeez. So when did you guys go up and reinstall the engines?
Mm-hmm.
Yeah,
we're getting pretty good at doing powertrain swaps on this car. Had to do it several times.
Have you thought of working for Hendricks when you get through the school? Engine swap outs?
It would be quite a bit of fun to work with a performance team like Hendrick Racing.
That's another secret, that Hendricks and Roush and those guys need to be looking at you guys, for to put on their team. They've got a bunch of engineers. Have you guys ever had aspirations of doing something like that?
We definitely look up to a lot of the performance cars out there, and we certainly believe that we have a lot of good ideas that we can share in that industry.
Have you been watching the Formula E development?
Formula E?
Yeah. The electric racing cars.
Formula One electric cars.
Yeah,
These things are unbelievable.
Yeah.
At 200 miles an hour on electric cars, and they're just like Formula One. The low drag and ground effects, and there's going to be a series starting next year. I think the first race will be in Miami, and there'll be several other locations in the U.S., but worldwide, this is going to be a huge thing. And I think looking in the tea leaves, at some point down the road, you'll see NASCAR doing electric vehicle racing. So,
I think the biggest thing that they're still going to be worried about is energy density and the weight of batteries. So when battery technology advances farther and they have lighter batteries available to them, they'll definitely be able to travel farther and really get into electric performance vehicles. I'm not sure how effective they'll be to start out with.
Yeah. I think it'll be interesting, like seeing the Formula cars doing pit stop to swap batteries, and I think they probably have to do that, like a couple of seconds, swap a new battery pack, and they just go.
Well, when you have a chance, do some research on this Formula E. Michael Andretti is involved in it. This is an awesome vehicle, and I wouldn't be surprised 20 years down the road that the gas vehicles that we're thinking about now, they just aren't even produced anymore. It's moving in that direction. So you guys are on the cutting edge of that technology for sure. So what are some of the issues and challenges that you've come up against here in the last several months trying to put this all together?
Right now, we seem to be having an interesting issue with our turbocharger in that when we get up to temperature and past it, it doesn't want to spool anymore. And so we're trying to figure out what's wrong with that system. With our turbocharger, it adds quite a bit of power and efficiency to our engine, so we want to make sure we get that working for competition.
So that's turbocharged. Now, the turbocharged on the diesel part of it?
Right.
Yeah. Wow. That is interesting.
Yeah.
So what is happening with it? Is it just is it cycling on and off, or what's happening with it?
When it gets up to temperature past around 65 degrees Celsius, the turbo doesn't. It's a variable vane turbo, which means that the fins inside can change geometry so that you can alter the amount of boost you have without a wastegate. And we have this issue where the vanes are just stuck open when the engine gets hot for some reason.
Folks, if you had any questions about a variable vane turbo, now you've had them answered. Thank you so much, Eric. You guys are awesome. It's incredible. So what's the next step? The
next step is to change the solenoid and see if that solves it. We seem to only be able to actuate the turbo full on or full off, and it seems to be stuck in full off. So we're going to see if that solves the problem.
Isn't it neat that you have advisors to go to if you'd like, but you're solving these issues on your own. Isn't that interesting?
Yeah, I never thought that I would come up against these issues that are so real world when I was applying to school. I always thought it would be about getting good grades, passing tests, and making a name for myself that way. But I never thought that I would be doing things like this. I didn't even know about engines before I came up with EcoCar, but I've just learned so much.
Jeez. we're almost out of time. We got about a minute left here. I want to go around it because this is really of interest to me. Okay, Matthew, going to start with you. 5 years from now, what are you going to be doing? Where are you going to be? What are you going to be doing?
I'll probably be working for some company in the automotive industry around the Detroit area, such as D-Space Incorporated. They're an embedded hardware control company. So working on embedded processors and the control software to go with them for controlling everything from something like our EcoCar to helping simulate entire vehicles for prototyping and analysis.
Well, very good. Yuchi, what are you going to be doing?
In 5 years, I think it's probably I'm going to be working as an engineer in the automotive industry, working with one of the automotive makers, maybe like GM or something like that. But long term, I really want to, like, whenever I got the fund and all that, I want to like open my own shop and do a high performance vehicle works and all that. That's really like I'm really interested in that.
Very good. So you got your 5-year plan and you got your lifetime plan. Beautiful. Okay, Stephen, how about you?
I'm personally kind of in the same boat as Yuchi. In 5 years, I could probably see myself working for a company like GM or GKN. GKN is one of the main driveline manufacturers in the country. They work with GM, Ford, and Dodge to create powertrain systems for the new vehicles. So I'd love to be in an engineering department with one of those companies and eventually start up a shop where I would be able to manufacture replacement performance parts for discontinued vehicles, say older muscle cars, or even imported cars, where I would be able to analyze a part and recreate it with less weight or better geometries to improve its performance.
Awesome. Derek, what's your aspirations?
Well, I know I'll be working probably with the hybridization and electrification of vehicles, but in what capacity, I'm not too sure yet. It could be performance, but it could also be for economical or even humanitarian causes.
Jeez, guys. Hey, look, we're about out of time. I want to thank you all for coming in and for having your short-term and long-term vision. Derek, Stephen, Yuchi, and Matthew, thanks so much for coming in and keep things going smoothly out there at ERAU.
It's our pleasure. Thanks so
for
much.
having us.
Thanks, guys. Well, that completes our show today, folks. I hope you enjoyed hearing from the guys from Embry-Riddle as much as I do. It's just what an awesome team they have out there. What an awesome school. We're so blessed to have them in our area. If you have a chance to get down there and see the new development, it's just incredible what's going on. It's just rising as fast as at the International Speedway. Stop by there and see the development too. Daytona is growing. Got to leave for now, folks. Have a good weekend. Talk to you next week.